Okay, we're talking about tilting now. So I want you to sort of think about the situation. There's two pivots, there's a plank, and Lewis is standing on the left-hand side, and he increases his weight. So what could this actually look like? Well, maybe he's like pushing down on the plank more and more and more and more until the rod is on the verge of tilting about support A, until it's sort of going to tilt off there. Well, what's going to happen at B if he pushes down, if he keeps pushing down more and more and more force here? What's going to happen is that's going to stay in contact there. But what's going to happen here? You can kind of see from the diagram. B is not really going to do anything. Yeah. If you have your seesaw here and you apply some pressure here, the support is there, but it's not doing anything. Yeah. So if we talk about tilting, and tilting is the key word, okay? You see the word tilt or point of tilting or something. What happens in these questions is we basically ignore something. So when a rigid body, that's a ladder, a plank, something like that, is on the point of tilting about a pivot, the reaction at the other support is zero. In other words, you can sort of delete, you can remove the other pivot, okay? Which is great because it actually makes the question into an easier one. We've gone from two pivots to just having a question about one pivot. The language, well, why do we say on the point of tilting? Well, you've seen so far, we like to answer questions about horizontal things because it's easier. So if we say it's on the point of tilting, we can get rid of that one, and then we can solve an equilibrium question with just one pivot. That's the idea. Example. A uniform beam, AB, of mass, blah, 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 blah. Let's, this uniform. Okay, so uniform, mass 45. Right, let's do this. So 16, so 8 is in the middle. So it's something like that. Okay, 45G. Let's get rid of that. All of the lengths are already labeled, so I don't need that anymore. Uniform, yep, I've taken that into account. I drew it in the middle. Support C and D, yes. AC is 5, CD is 9. Yeah, I've got all of that. When he stands on A, the beam is on the point of tilting about C. Well, think about it. Put the pressure on this end here. What's going to happen? That will stay in contact, and this one's going to disappear, isn't it? Okay, so you're going to be left with a situation like this. Some mass mg, some reaction here, and some downwards force 45G. Now, it's a little bit untidy, okay, but hopefully you can see there, that's now a fairly basic question. So you're left with, well, let's just remove it so we've got a clean copy. You're left with that as your question. Well, you could just take moments maybe from Lewis or from the pivot. It really doesn't matter. Here they've done from the pivot. So look, 5 to the left is perpendicular, 5 mg. That's anti-clockwise, is equal to, on the other side, you've got 3 times 45 is equal to that. So we can find out we can find out Lewis's mass fairly simply. So tilting questions are actually really, really nice questions, okay? Because they take a lot of the difficulty out of the question. One other thing, well, I suppose one other thing I would say here is take moments at A, because you don't know mg. That's not a bad idea. Take moments at the middle. It's a pretty good idea as well. You didn't know R, and look, you didn't have to use it in the working out. So that was a good place to take moments. If we tried to take moments over here, this would have been a pretty bad idea. Why? M, you need to use M, you don't know M. R, you need to use R, you don't know R. Okay, so this step here sort of just says, take moments at points where maybe there's something that you don't know is a very, very good strategy, okay? Because you don't always have to work out all of this information. If you're selective about it, if you take your time, you can remove unknowns from the question that way and maybe work them out later. And that really is it. So that's tilting. That's all you do for the tilting section. Let's just talk very quickly about one more kind of example, because all of the questions so far have really discussed seesaws, more or less, seesaws and balances, but they don't have to be like that. You can have suspended examples. So what I mean by this is I want you to think of about like an old-fashioned light hanging in an office or a library or like some sort of big room. And you have a light and then you have strings. You would have strings holding onto the lights. And everything that we've done, you can do about these as well. But students get a bit confused about these sometimes. So if you have a light, a strip light they're called, a strip light here, well, it's got some weight down, but what's it being done? It's being held up. There's tension hanging it up. So instead of reactions from pivots, you might have tension, strings pulling something up. So we can still answer questions about this sort of thing too. A non-uniform rod, watch out for that. 10 meters, weight, look at that. They've told you the weight. They didn't tell you the mass to find the weight. No, they just told you the weight straight away. That could cause some problems. We do not want to put 40G, just 40 for that one. It's suspended from a pair of cables attached to C and D. AC is 3, BD is 2. So the whole thing is called AB. AC is 3, BD is 2. And the thing is 10 meters long. Yeah, this is what you want to be doing with this kind of information, being able to get those distances right. When a weight of 25 newtons is hung from A, so in other words, we're talking about doing something like this, 25, not 25G, 25. When it is hung from A, the rod is on the point of rotating. Well, if it was like this, and you put some weight there, and it's about to rotate, which string is it going to ignore? The string that it's close to, or the string that's the other side of it? Well, these are the distances. They've called this distance X because it's a mystery how far away it is, the center of gravity. These are the tensions in the string. So if you put this block on here, it wants to go like that. In other words, this string is going to become slack and it's not going to do anything. You can completely ignore them. Once you've chosen the right one, you can ignore that part there. And look, we've now got a question, haven't we? Find the distance from A. Well, if you're talking about from A, you could do moments at A. Yeah, you could do moments at A. So what you could do is you could say, well, if you're from the end here, you can ignore that. That's 3t. 3t is anti-clockwise. X times 40, or 40x, that's anti-clockwise. Sorry, that's clockwise. Problem? What's the problem here? Problem is that you do not know, you don't know t and you don't know x. So that might not be the best place to pick it from. Maybe we could pick an easier place. So maybe we pick the moments here instead. On this occasion, I might do that. I think it's probably easier. So 25, 3 to the left. So that's 75. Yep, just 75 on the left. And here, this distance, what's this distance? Well, it's x, but it's 3 less than x. So it equals x minus 3 times 40. Look, there you go. That's a much easier one to solve. So that's probably the way that I would solve this one. Yeah. The center of mass then is 4.875. Double check your answer. The whole thing's meant to be 10 meters. So the answer needs to be less than 10. So that sounds about right. And that is it for, that's really it for suspended examples. Instead of talking about R and 2R, or sometimes R and S, okay, instead of doing that, we just replace them with t's. Okay, so you normally talk about t and I don't know what the other one could be, the t and p or something like that, some other letter. I'd like you to pause the video now then, have a go at this example as well. Think carefully about which support, which string you can ignore if something is on the point of tilting. So your diagram should look like this. When it is hung from B, it's on the point of tilting. So this one is going to go. Okay. Makes sense to take moments from here because they do not ask you what the value of t is. So again, it's like the one from before. Taking moments from this point here is probably the best idea. So notice there's no like hard and fast rule about where to take the moments. Generally, from the ends is probably the most common way, but there are situations, tilting I would say more so, where often it's a good idea to actually go around sort of the pivot section, which is the tension in this case. Okay, and moment will be back. Okay, so you need to make sure you really are quite well grounded in these concepts because later on it does return. It does tend to get a bit more difficult. It's all about a force and a distance that are perpendicular to each other, and this is about turning. Resultants mean overall what happens, and many of the questions use equilibrium. Equilibrium means the moments will be equal, but also up and down will be equal. That's something that's quite useful to you sometimes. Non-uniform, you cannot assume that the mass is distributed evenly, so you don't put the weight in the middle. You call it a mystery distance if you don't know. Finally, tilting. Tilting makes questions nicer. Once you take your time to understand what's going on, you can ignore, you can sort of block out one of those forces. So that takes you to the end of moments.